In the last days of April 2019, a telescope in Australia was pointed at the nearest star to our sun. It was not hunting aliens that night, it was watching a storm. And for 5 straight hours, something narrow, something clean, something that should not exist, sat quietly inside the noise. Nobody noticed, not for a year and a half. It was buried in 30 hours of recorded sky, in a file that nobody had opened yet, just waiting. The star is called Proxima Centauri, 4.2 light-years away, the closest sun we will ever have that isn't ours. And it has a planet sitting in its habitable zone, a world called Proxima b. In 2020, an undergraduate intern named Shane Smith was given the boring job. Sift the data, flag anything strange, and he found it. 982.002 megahertz, one frequency, impossibly thin. Here is why a thin signal is terrifying. Stars are messy, explosions are messy, everything in space smears itself across the spectrum. A single razor-thin tone is the fingerprint of a machine. And this one was drifting. Drifting means moving. The frequency was climbing, 0.038 hertz, every second. Exactly what you would expect from a transmitter riding on a spinning, orbiting world. But here is the part that stopped the room. It drifted the wrong way. Earth's own rotation should have pushed that frequency down. This one went up, which meant the source was not turning with us. It was somewhere else. So they pointed the dish away from the star. The signal vanished. They pointed it back. It returned. Away, gone, back, there. Again and again, it followed the star. That one test kills almost every false alarm we have ever had. It did not kill this one. For 8 months, a small group of scientists lived with a secret. A narrow-band signal, drifting correctly, appearing only when the dish faced the closest star to Earth. They gave it a name that sounds like nothing at all. Breakthrough Listen Candidate 1, BLC-1. Then, in December 2020, it leaked. And the world did what the world always does. Headlines, everywhere, a signal from Proxima Centauri. And the scientists who found it begged everyone to slow down, because they were already trying to prove themselves wrong. A doctoral student named Sophia Sheikh took the file apart, and instead of asking, "Is this aliens?" she asked a far better question. If this thing was made by us, then where are its brothers and sisters? So she searched the same recording, around the same frequency, for anything that looked even slightly like it. She did not find one. She did not find 10. She found 5,160. 5,160 ghost signals, hiding in the very same sky, and every single one of them was born on Earth. BLC-1 was never a message, it was intermodulation. 2 ordinary Earth transmitters bleeding into each other, mixing into a brand new frequency that existed in neither of them. A cracked oscillator, an overdriven amplifier. Somebody's broken electronics somewhere in Australia, singing a note that sounded exactly like a civilization. On October 25th, 2021, it was over. 39 more hours of listening. Proxima never spoke again. But turn it around. For 100 years, this planet has been screaming across the radio spectrum. Our engines, our satellites, our broken amplifiers. So if someone 4 light-years away is running the very same search we are, pointing their dish at a small yellow star, they are not going to find our message. They are going to find our interference. We are somebody else's BLC-1. 49 years ago, a telescope in Ohio caught 72 seconds of something sitting on the hydrogen line. An astronomer circled it in red ink and wrote a single word: "Wow." We have never heard it again. Every one of these signals eventually gets an explanation, except the ones that don't. And somewhere, in a file nobody has opened yet, the next one is already waiting. The universe isn't finished being drawn.